You've got to correct them, right? And it's true, we want students to understand certain basic facts and how to use them. But saying yes is not the same thing as saying you're right. You can accept ideas, even wrong ideas, into the debate and say yes to your students' right to participate in the act of thinking mathematically. To have your idea dismissed out of hand is disempowering. To have it accepted, studied, and disproven is a mark of respect. It's also far more convincing to be shown you're wrong by your peers than told you're wrong by the teacher. But allow me to take this a step further. How do you actually know that 2 plus 2 doesn't equal 12? What would happen if we said yes to that idea? I don't know. Let's find out. So if 2 plus 2 equaled 12, then 2 plus 1 would be 1 less, so that would be 11. And that would mean that 2 plus 0, which is just 2, would be 10. But if 2 is 10, then 1 would be 9, and 0 would be 8. And I have to admit, this looks bad. It looks like we broke mathematics. But I actually understand why this can't be true now. Just from thinking about it, if we were on a number line, and if I'm at 0, 8 is 8 steps that way, and there's no way I could take 8 steps and wind up back where I started. Unless, well, what if it wasn't a number line? What if it was a number circle? Well, then I could take 8 steps and wind back where I started. 8 would be 0. In fact, all of the infinite numbers on the real line would be stacked up in those 8 spots. And we're in a new world. And we're just playing here, right? But this is how new math gets invented. Mathematicians have actually been studying number circles for a long time. They've got a fancy name and everything, modular arithmetic. And not only does the math work out, it turns out to be ridiculously useful in fields like cryptography and computer science. It's actually no exaggeration to say that your credit card number is safe online because someone was willing to ask, what if it was a number circle instead of a number line? So, yes, we need to teach students that 2 plus 2 equals 4. But we also need to say yes to their ideas and their questions and model the courage we want them to have. It takes courage to say, what if 2 plus 2 equals 12, and actually explore the consequences. It takes courage to say, what if the angles in a triangle didn't add up to 180 degrees? Or what if there were a square root of -1? Or what if there were different sizes of infinity? But that courage and those questions led to some of the greatest breakthroughs in history. All it takes is a willingness to play.